Hello, everyone. My name is Haley Cassidy, Americhem's Global Branding and Digital Marketing Leader. I'd like to thank you all for joining today's webinar, 3 Must-Have Functional Additives, which is part 1 of this series, Nonwovens. Today, we will be teaching you how to equip your team with the right tools to meet emergent customer demands for functional nonwoven materials. We'll also cover today's most in-demand in-melt additives that will transform the way customers interact with your materials. All attendees are muted, so please send in your questions through the questions tab, and we'll address them at the end of the presentation during our Q&A segment. Today, we will start with a brief introduction of our panelists and who Americhem is, followed by explaining the benefits that additives can provide to your end application. Then we'll dive into why you would use the in-melt approach and the exciting world of soft, hydrophilic, and durable nonwovens. We'll also be covering the re-emergence of antimicrobials in 2021. Lastly, we'll take your questions that you send in during the presentation. Today, I am joined by Robert Baldy, Americhem's Sales Manager for Fibers, and Roger Threadgill, Americhem's Product Development Manager for Fibers. I will now turn it over to our panelists for them to give brief bios of themselves, followed by the rest of the presentation.
All right, thank you, Haley, and thank you to everyone who's attending the webinar today. We appreciate you for joining us to discuss additives in plastics. As Haley indicated, my name is Robert Baldy, and I am the Fiber Sales Manager here at Americhem. My professional background has been focused in synthetic fibers, specifically in the nonwovens industry, where I've worked either directly for a nonwovens manufacturer or, like I am now, in a support role to that particular industry. This includes my 8 years with Americhem, during which time I have been working in concert with my colleagues to provide solutions to the synthetic fiber space. Presenting with me today is one of those colleagues, Roger Threadgill. Roger?
Thanks, Robert. Well, as you've heard, my name is Roger. I'm the Technical and Product Development Manager for Americhem's Fibers Group. I've been with the company for over 30 years, with the vast majority of that time spent in either designing, manufacturing, or developing product solutions for the fibers industry. Thanks you to everyone for joining us today, and turn it back to Robert.
Great, thank you, Roger. Americhem is a global partner to many of the companies on this call and many others across the globe. We specialize in performance master batch and fully compounded polymer products. At Americhem, we seek first to build trust based on relationships with our customers by offering innovative solutions that optimize performance. Delivering customer preferred solutions has been an Americhem hallmark for 79 years. And as we work through the content today, a note to remember that all the additives that will be discussed are available globally thanks to our 900 very talented people that are Americhem. Our ultimate goal is to partner with you in transforming the way your product looks, feels, processes, and how it endures its unique environment. Illustrated here are a few of the major industries leveraging the unique properties of manufactured fiber. Many of you in attendance represent one of these markets and thus fully understand the demanding requirements of today's consumer. While the focus today will be additive applications in nonwovens, many of the chemistries that we discuss can be or have been adapted to suit other areas. Americhem brings over 30 years of experience as an industry leader in fibers, offering a wide array of color and additives matched to deliver on the requirements specific to turf, carpet, apparel, and other textile-based applications. Americhem's offerings in the synthetic fibers area encompass several branded product families. As you'll note, again, with a focus on nonwovens, our overarching brand is Envision, which covers our color and additive offerings. Today, we'll cover many of the sub-brands within the nonwovens range, which also span the other markets as we covered on the previous slide. With diversity being evident in a wide array of end uses, a unifying need in this space is to deliver affordable innovation that drives consumer preference. This is true whether you operate in a market demanding a long-term product such as carpet or a single-use disposable one such as a face mask. Meeting or exceeding customer expectations requires a manufacturer such as yourselves to unify a complex set of variables, tracing all the way back to the incoming materials. Today, we will be covering some of the product families shown as we step through the discussion. As we prepare to do so, let's take a look at why additives are critical to any fiber manufacturer's portfolio. The pace of change in today's world continues to accelerate, and a glaring example of this is the shifting landscape of consumer preference. Today's consumers are specific about their expectations and are demanding more than product ownership in the form of an overall experience and value alignment with the products with which they engage. These needs are not met by a set of commoditized product offerings. Now more than ever, innovation and differentiation are key to capturing preference and the ever elusive prize, brand loyalty. Incorporation of additives enables product customization that can be turned on and off as needed, depending on the demands of the application. Further, taking an in-melt approach to the incorporation of additives may reduce manufacturing complexity while delivering efficacy, efficiency, and permanence that generally surpasses other methodologies. And with that introduction, I'm going to turn it back to my colleague Roger, and he's going to take us deeper into a few of the specific additive technologies. Roger?
Thanks, Robert. So when selecting the proper additive solution for our polymeric fiber system, what types of attributes are important? As an engineer by training, I tend to view this problem like I view most problems, as an optimization routine. For additive selection, we can look at answering 4 basic questions. What is the function of the textile? What is the textile's environment like? What polymer is the textile made from? And what level of performance is needed? That's just 4 questions. It seems pretty simple, right? But if you take a closer look, under the second question, what is the textile's environment like? There's a whole subset of items that need to be defined to be able to make the best selection. Is this product going to be used indoors or outdoors? Is it a durable item or a single-use item? Sorry about that. Will it be laundered, or what does this maintenance activity for this item look like? Does it have food contact or other regulatory requirements, and so on and so on. And each of the other questions has its own specification set, which, if we answer all of these correctly, will give us the optimal additive solution for our performance. So let's take a look at our first additive class, hydrophilics. A classic definition of hydrophilic would go something like having a tendency to mix with, dissolve in, or be wetted by water. In other words, water loving. And if we think about it, most polymers are derived from byproducts of what commodity? Yep, that's right, oil. So they might need a little help overcoming any natural aversion to water. We can think of in-melt additives of this type like being sort of a special internal soap that will allow the materials to mix together better, with water being the main one that we're looking for. So as we look at the design criteria, one of the major questions that we have to answer is, can we process it? Will it be extrudable? Or in other words, capable of surviving extrusion? Things like heat stability, dispersibility are probably the most important questions to answer. What reaction to water do we need to promote? What are we needing to do? Are we going to move water through the article? Are we helping manage the thermal environment in some way? Or simply making the fiber wettable? These are the key considerations for the design. And as always, whether it's personal protective equipment or some hygiene application, the regulatory compliance is a key consideration in the nonwoven space. So take the 3 active modes when it comes to interactions with water. Whether you're wicking moisture, are you absorbing moisture, or you're wetting the textile, these are probably 3 unique and different properties. And there are 3 separate test criteria that are used to define the performance of each. So we can use those to test out our relative performance. Take the first example, absorbing moisture. We look at that through what's called intrinsic absorption. So we take a look at a spun-bond nonwoven sample here that was treated with 5 different additive chemistries to see how many times their body weight in water each could absorb. The samples with 2 bars means that we looked at 2 different dosing levels. If you only see one, then we had an issue with producing the web. Back to our original design criteria when we were asking whether or not this additive would be extrudable. In this test, additive 3 and additive 1 look most interesting. Note the higher levels of absorbency and the fact that the 2 different levels were in fact processable. So if we're interested in wettability, we can get a sense of that attribute by looking at what's called the contact angle. This is a measure of the surface tension of the web, or if you will, the balance of adhesive and cohesive forces of the water and the web. In our example here, 2 nonwovens are tested, one treated with an additive that modifies its interaction with water significantly versus one with little to no impact. So in evaluating the drop formation on the sheets, this gives us an insight into how wettable the nonwoven should be. The contact angle of the drop tells us the story. Our third mode of interaction with water is wicking. Our pictures here are a little skewed on the slide, but we are comparing topical treatment nonwovens versus that of an end melt in terms of the wicking property. One of the more demanding tests is the ability of the material to wick or draw water up the length of the specimen. This sets up sort of a capillary action that is working against gravity, conducting the water up the length of the specimen, not in direct contact with the water. The demands on the nonwoven's performance continue to increase almost all the time. So the technology continues to advance to try to keep pace and provide a better performance while maintaining or lowering the cost to meet the requirements of the technical fabrics. So now we'll turn our attention to softness modification, or haptics, which in some ways is a close cousin to the hydrophilic attribute we just reviewed. The sensation of soft is actually a system of multiple sensations. So what are the different facets of the soft or tactile quality? Is the surface slick? Or is it more cottony or textile-like? What is the drapeability like? So this can also be related to thermal management as well. Different technologies can be used to impact the different facets of soft. Our Embrace family of products has been in the market for several years with our first and second generation products that are utilized to increase the slicky feeling in the nonwovens. So along with the soft facet, here are a few of the design criteria used in the product development. You look at the internal valuation where we were looking at touch and feel, obviously. There's also the thermal stability analysis to understand how extrudable, again, this product could be, or this additive system could be. We look at filtration, which is very important in the fibers industry overall. We do that a couple different ways. And then we want to look at the rheology as well. So the master batch must be able to disperse, mix, and incorporate into the polymer melt from a resulting nonwovens without disrupting the web forming process. So thermal stability is obviously critical. Can it survive? The extrusion process is going to be melt blendable. And then the rheology, how does it mix and incorporate into the polymer matrix during the extrusion? These are the kinds of things that we look at when we're looking at designing in attributes. So here we have the full product family, with some involving extensions into adjacent nonwovens technologies, along with the facets of the soft experience it impacts. The cottony or textile-like, low coefficient of friction or silk-like, and even drapeability. You'll notice here that some of these are designed for use in spun bond versus melt-blown processes, and even polyester versus polypropylene. This next slide has the same product, but it's in more of a visual map with the facets of soft and heat stability listed there on your left axis and your horizontal axis, and then also price listed on the right side on your right vertical axis. This kind of relates the relative cost versus performance versus facet criteria that you're looking for. And now for something completely different. So far, we've been talking about properties most important to hygiene and other wearable applications. Our next topic is more important in more of the durable application space. UV resistance is a major component of the overarching topic of weatherability. UV radiation, which is one of the main causes of polymer degradation in weatherable applications. And there are some other contributors as well, things like frost, freeze, and thaw. What's the temperature range that the article may be exposed to? What types of pollutants might be in the environment? And is it going to be placed under any kind of mechanical stress? This is a complex, interconnected system of factors that contribute to the breakdown of our textile fabrics when used outside. I'm sure that all of us have seen this with the products that we use every day, whether it's the cover for our grill, out on the deck, or sunbrella over our picnic table. We all have seen textile fabrics degrade to the point of ripping, tearing, and shredding at some point. So today we're going to focus on mitigating the degradation due to ultraviolet light. So what are some of the tactics that we can use for this strategy? Well, UV absorption. We can absorb the UV and convert it to heat or some other form of energy before it can interact with the polymer. UV scattering. Can we bounce the UV out of the polymer before it actually interacts? Antioxidation. Since most degradation is related to cleaving and oxidizing of the polymer chains, can we prevent that? And even radical scavenging. Byproducts of chain scission can be tied up before wreaking more havoc on the polymer chain itself. And there are a few others. We don't actually talk about PET and nonwovens a lot, but it is the second most widely used polymer behind polypropylene. For polyesters, primarily we impart weathering resistance by protecting the fiber from UV radiation. In our study here that we're going to look at over the next couple of slides, this is a polyester filament. It's a 4.4 DPF round fiber. It's untextured. We took care not to try to induce any sort of surface damage on the fiber, so we left it as flat. We utilized ASTM G155 specification, which is pretty good approximation to outdoor weathering. We did the exposure length for about 240 hours, which is equivalent to roughly 180 days outdoors. And we checked these at 3 different levels of stabilizer, or three different exposure levels, I'm sorry. Percent retention, more specifically, tensile strength retention is the measure we're going to use. So the strength at each interval compared to the unexposed fiber gives us the sense of the relative polymer damage. Outdoor fabric, so we're looking at something that would be used outdoors, something like a geotextile maybe, or construction fabric of some sort. So this experiment looked at the performance of 2 members of our Enduramax family of UV stabilizers and their impact on the UV resistance of the polyester film. The first 2 data sets in the trial are composed of only polyester by itself and then PET plus titanium dioxide. So each bar represents the 3 exposure times in each set. So we looked at 80, 160, and 240 hours exposure. So this illustrates the relatively low impact of the TiO2 addition to the polymer, at least in this type of exposure. Our second set of trials looks at the incorporation of what we're calling package number 1 here at 3 levels at the same exposure intervals. These samples do not contain any TiO2. From left to right, the additive level increases, and the corresponding tensile retention value increases as well. The stabilizer is having an impact, but you might want to take note here of the $sign. That'll be important later. On our third set of data trials, we looked at package number 2. It's similar to package 1 in that the retained strength at each exposure level increases with an increase in the additive level. And in fact, this package appears to be more efficient than the first package as the level increases. But note there are $4 signs next to this package. This highlights another major consideration, that higher efficiency sometimes comes at a price. Package number 2 is more costly than package number 1. There's an opportunity here to over-design, and that's always a danger that we have to keep in mind in any project. So taking care to specify and define the actual level of performance you need is very critical for the success of any project. Lastly, on slide number 4 in the series, this looks at the impact of 3 different colorants on the EnduraMax package number 1 at our mid-level. So you'll notice in the spectrum, our colorants will reflect and absorb different parts of the visible spectrum, but they also interact in the UV and IR regions as well. The good news here is that even with that fact, package number 1 gives a strong protective effect in combination with these different colorants. And now I'll give it back to Robert so he can share some additional information with you concerning our other additive systems that we offer. Robert.
Yeah, thank you very much, Roger, for that comprehensive discussion on multiple additive categories. Today, we looked at 3 categories and some specific application areas for each. Considering the proliferation of use of nonwovens materials, the application space for soft, hydrophilic, and UV additives has expanded significantly in the past several years. These, plus multiple other functionalities, are available and enable today's nonwoven manufacturer to customize and differentiate their product portfolio. The ever-shifting retail landscape has made this a critical component to capturing the attention of today's end consumer. And as you can see, there's other product categories we've listed here, antimicrobials, which we'll talk more about in a second, antistats, FRs, hydrophobic, and optical brighteners are a few of the major classes of additives that are also used in the nonwovens arena. As we wrap up the session today, we're going to check back in on a topic Americhem covered extensively in 2020, antimicrobial additives. With the onset of the pandemic, interest for introducing antimicrobial activity into a wide variety of products peaked. Americhem offers a customized approach to incorporating antimicrobials into synthetic fiber applications. For a refresher on this technology, visit our website as noted on this slide to find the prior webinar presented on this topic. The title of that webinar is Antimicrobials in Fibers 201. Or feel free to reach out directly to Roger or me for further discussion on antimicrobials or any other additive areas of interest that you may have in follow-up to today's discussion. This concludes the presentation part of today's online seminar, and with that, I'm going to turn it back over to Haley, who will lead us through the Q&A. Haley?
Thank you, Robert and Roger. That was a very interesting and relevant presentation. We'll now move on to the Q&A portion of our webinar. I'll be reading off the questions that have been submitted so far and pass them on to our panelists for answering. So again, as we're going through the questions here, please continue to send in your questions and we'll try to get to as many as we can. So our first question is, do you offer any additives to help the appearance of recycled PET in fibers?
Sure, I'll take that one. Yeah, we do. Actually, we offer a product called Renewal, PET Renewal. That product basically does a good job of masking some of the color variation or off color you might see when you process recycled polymer content back into a fiber form. It does a good job because it basically operates by absorbing radiation in the non-visible parts of the spectrum and then re-emitting that in the visual. So it gives you a little bit of extra energy, gives you a little more brightness and a little more pop on the shelf. So our PET Renewal additive will do a good job there.
Okay, our next question is, what additives do you recommend for non-woven hospital gowns and other similar healthcare fabrics?
Well, that can be a complex category. We currently operate in that space primarily in one of the areas areas that we covered today, which was our softening portfolio. Obviously, the comfort of the gown is critical to the wearer, and so those softening additives have become a critical piece to the nonwovens medical gown area. Another potential application, obviously, one that would spring to mind that we covered at the end here was antimicrobials. There's been a large interest in adding antimicrobial additives to hospital gowns. And then finally, we've worked on programs to where in today's world, most of the hospital gowns are treated with both a hydrophobic and also in many cases an anti-stat type material. In many cases, those additives today are done topically, but we've worked on technology to also enable a nonwovens manufacturer to put those in an in-melt form. So just in summary, soft, antimicrobial, hydrophobic, and anti-stat are the typical product categories that we would see for a nonwoven hospital gown.
Okay. Our next question is, are you able to control the level of softness that we may need for an application? Our products range in softness levels.
Yes, I would say, very good question, by the way. I would say that typically we can manage that either through product selection and or even dosing level on the particular additives themselves. So typically you're going to get a recommended range of applicability. So one of the ways that we recommend dealing with that is when you want to vet out some of these different soft technologies would be to run a ladder study on the chemistries that you'd be interested in there, whether you're trying to deliver, again, that cottony feel or potentially even the silky feel. Running a range ladder study on that should be able to help you dial in the level of softness that you'd be interested in.
Okay, our next question is, what are some examples of hydrophilic nonwoven end applications that you have worked within?
Yeah, so we've looked at a variety of different hydrophilic applications. One that you may think about that is fairly obvious and prevalent, particularly in today's world, is wipe applications. You know, there's a variety of different applications and in uses, obviously, in that market space. And then probably the other primary category would be hygiene type articles. So your diaper or your pant type applications are another space that are where the hydrophilic, a desire to impart hydrophilicity or modify the inherent hydrophilicity of polypropylene is appropriate and it is regularly used.
Okay, our next question is, in Asia, nonwoven PET is ongoing but done with rPET. Do you have something to recall the original IV?
There are technologies available that tend to try to reverse the effects of what we would call chain scission, where you would lose your intrinsic viscosity property through breaking of the chains, especially during in some sort of repelletization process or something along those lines. So there are technologies available that are geared towards repairing some of that damage, and that's definitely something that we could talk with you more extensively about.
Okay, next question. Is there a big difference between topical finish versus inherent polymer finish or melt spun for antimicrobial finishes on PET fibers?
Yeah, I'll throw in my 2 cents and then Roger will probably upgrade the discussion a bit. as you look at topicals, they are a prevalent approach, and they have been a prevalent approach, particularly in the antimicrobial space, for some time. Obviously, the advantage of topicals is that they typically can be added at fairly low levels at a fairly economic price point. But as you deploy that approach to antimicrobials, the area that you have to worry about is long-term efficacy. So obviously that would become less prevalent for single-use disposable type articles. But if you're looking to impart long-term efficacy of an antimicrobial, an in-melt approach is far superior because it is inherent at that point in the fiber versus on the surface, which can easily be taken off with laundering or some other approach that may happen to an article like a sock or an athletic apparel. The other reason why an in-melt approach could be superior is a topical application requires supplemental equipment that not all nonwovens manufacturers have, some type of treating system, and then also a follow-up drying system. So you have equipment cost that you have to consider on the front end, and then also ongoing energy costs that would not be a factor when you're using an in-melt additive such as what we would offer. And I don't know, Roger, if that kind of covers the primary aspects or if you have something else you would want to add.
No, Robert, I think that's a pretty good description. So it's summarizing two major aspects, and what's the articles or the textiles environment going to be like? Is there any kind of maintenance activity on it? That kind of tends to drive that decision in terms of the the durability of the antimicrobial activity that you need, and then the secondary question around process concerns. Are we going to have to incorporate a secondary process in line or offline to making the nonwovens? I guess the nice thing about in melts is once you do the actual forming and rolling, it's ready to go, and there's no extra processing that needs to be done. Nice job, Robert.
Okay, so we are at our 30-minute time limit here, but we have a lot of questions coming in for our panelists. So we'll go for another couple minutes here till about 9:45 Eastern Standard Time. If time permits that you're able to stay on the webinar, please do. If not, we'll be posting this recorded presentation on our website early next week. I'd also like to briefly mention here how you can ask us further questions before we jump into some of these other questions asked here. If you have any other questions, you can certainly connect with our panelists on LinkedIn, but you can also go to the Americhem website and ask us questions through the instructions on this slide. If you go to americhem.com and click Contact Us and then choose the contact form that states I have a general corporate inquiry and choose the option to send the contact form to marketing. I'll be receiving all of these questions directly and follow up as soon as possible with our panelists. You can take a screenshot of these directions, but we'll also be sending out an email with the directions in it as well. So our next question that we have here is, can you please explain the difference between non-woven and woven?
Well, sure. So that comes back to your forming process or how the article is constructed, put together. So a non-woven process is a mat that is formed with a randomized laydown of fibers. And then those fibers are tacked together with some type of bonding technology, be it thermal or chemical or physical. Whereas for a traditional woven article, that would be your more and I'm going to use the word traditional again, even though I just used it, but your more traditional articles that that you see in many of your regular daily activities. So, a prominent example of a woven article is something like a shirt or an article of clothing. Those are constructed and the fibers are woven together, again, in the consolidation or in the forming process of that specific article.
Okay, next question is, do you have additives that can prevent carbonization during manufacturing? Would a hydrophobic be useful for this case?
So carbonization, I tend to think of that as you're concerned with some sort of degradation effect on the polymer. That is definitely can be addressed to some degree of efficacy through use of antioxidants. The carbonization, as I'm understanding the question here, probably related to an oxidation of the polymer to some degree, probably pretty severe oxidation of the polymer. So incorporation of an antioxidant package sometimes can do a lot and go a long way into relieving any sort of issues you may see with that, whether that translates into deterioration in pack life, for example, or discoloration, or black specking, sometimes even in the polymer that makes it through the screen pack and gets into your woven structure there. So probably a good idea to use that, and we could definitely help you with the selection of the proper system to prevent that oxidation reaction.
Okay, next question is, can the strength of viscous fiber be increased by using a finish?
So viscous fiber is not an application space that we typically operate in. So your viscous fibers are not in a melt extruded type application. And then further finishes, we, again, our approach to this space is through an in melt type additive. So I would say that we have not done any exploration in that particular aspect, but I'll check that answer with Roger just to make sure.
No, Robert, I'd say that's pretty fair characterization. Not really a space that we operated a lot in, so yeah, I think we would probably leave it at that.
Okay. Next one is, in which way are hydrophilic additives added in the extrusion process, spraying, etc.? Thank you.
Well, I think yes. To the question there, they are potentially added via in melt, as we've been talking about today. Also topically added, which I think Robert described that process to some degree in the discussion on another topic earlier. And yeah, so again, if you're going to do it topically, you're talking about addition, you're talking about padding, you're talking about drying, and then again versus the in melt, which it's probably becomes intrinsic to the fiber as produced, and it eliminates the need for those different secondary steps on the application.
Okay, and another one, is your antimicrobial registered with Ecotox?
Ecotox, that would be one that we would have to go back and check on to be sure. I would hate to misspeak and tell you something that wouldn't be true. All the ones that we work with, especially here in the United States domestic market, are going to be registered with the Environmental Protection Agency here, also with the governing bodies in Europe. So Ecotex is a different one. I think we'd have to go back and check on that for you, and we'd be glad to do that and respond appropriately at that time.
All right, well, that was our last question. So that wraps up our Q&A portion of the webinar. I'd like to thank our panelists for their time today, and I'd like to thank all of our attendees for joining Americhem in this very important discussion about additives in nonwoven fibers. So thank you again for attending our webinar today, and that concludes our presentation.
Yeah, thank you, everyone. We appreciate you allocating your valuable time to the presentation today.
Yeah, thank you, everybody. Appreciate you joining us.
Thanks, guys.